Hey everyone, and welcome back to another 3D revolution. In earlier episodes of this series, I've looked into biodegradable and environmentally friendly filaments and things that you can do to help reduce the negative environmental impact of 3D printing. But not only can you reduce the negative environmental impact, you can actually use 3D printing to help aid the environment in general and to reduce negative impacts elsewhere. So in this, the final episode of the series, I'm going to be looking into things that you can 3D print which will have a positive impact on the environment, tweaks you can make to your 3D printing habits, and fun projects you can try at home. I've said it before, but for me, one of the biggest things that 3D printing has to offer, beyond being able to design and print bespoke parts of your own that just don't exist elsewhere in the world, is the ability to design or download and then print a spare part for something you already own which is broken. Three of the big things that currently plague our world is landfill, the amount of stuff that's just being thrown away, an overconsumption of resources, the amount of materials needed to make those things in the first place, and the carbon footprint involved in getting those resources, transporting them to a factory, producing the product, and then shipping them to consumers. 3D printing has the potential to bypass a large part of all three of those issues. Too often a small part of something breaks, and even if the owner then puts up with their flaws for a while, ultimately it's probably going to end up being thrown in landfill, and then a whole new item is going to need to be produced and shipped out to them to replace it. 3D printing, however, allows you to either download, or if you've got the know-how, design, and then print a spare part, and then allow you to make your broken item as good as new. I've designed and published a few things on Printables and Thingiverse which help people repair things which are broken, such as the zip toggle replacement, which has helped hundreds if not thousands of jackets, bags and cases be repaired rather than just thrown away into landfill. But there are countless people which have designed some fantastic repairs for all sorts of things, from bag clips to drawer handles, desk chair parts, door hinge parts, Ethernet cable parts, bike and car parts, hell, even parts to repair a broken doll. Even 3D printing a repair or replacement part for something that has an official replacement part you could order is likely a more environmentally friendly option than the sourcing, manufacturing, packaging and shipping of that official part. By the same token, 3D printing a whole new thing rather than ordering it online or buying it from a shop would likely have a smaller carbon footprint. Whether you use 3D printing to repair something that's broken or print a whole new item rather than buying it, even though 3D printing something generally uses much more electricity than injection molding the same part, it's likely going to be a much more environmentally friendly option. Yes, 3D printing requires electricity, and that reel of filament needs to be shipped, and also often comes in 2 to 3 layers of packaging, but that shipping and packaging is for a whole kilogram reel of filament, which can then go on to print tens if not hundreds of replacement and brand new parts. That shipping and packaging and energy requirement becomes negligible then when compared to the amount that would be required for the same amount of parts from a shop. So what do you do if you've got a pile of failed prints in a material that isn't biodegradable or recyclable? Well, you can still reuse these at home. Store up all your failed prints and your stringing and your support material, because even if it's failed or superfluous, it's still a thermoplastic. You can still melt it down and pour it into a mold. You could create coasters and placemats, and if you're creative enough with your mold, you can pretty much create whatever you want. I've even seen people use this technique to use scrap prints like liquid resin for filling in holes in tables and other furniture. Further to that, you can now get machines that will melt down your failed prints and scraps of a particular material and turn them into a reel of recycled printer filament ready to use. This can be really effective, and if you don't have the money to buy one of these machines, there are open source designs where you could build them yourself. Later this year, I'm going to be doing a video or two on a project which will allow me to take used plastic drinking bottles and turn them into a reel of PET printer filament. Many things that you do to help save the environment can also help save you money. And regardless of whether you're printing an ABS or one of the biodegradable filaments that I've been looking at earlier in this series, they're still costing you. One way to reduce your cost and the material usage and your print time is to reduce the infill of a print. Many prints don't require the infill to give them the necessary strength. So reducing the infill is one way to go about that. And one thing that you can do is to print it in vase mode, which just prints the perimeters. However, due to how vase mode works, not all models will work as a vase mode print. And unfortunately, printing a 0% infill model isn't going to necessarily work either, because some models are going to require infill to act as a sort of internal support structure to give the top layers something to print onto. In these cases, you can massively reduce the amount of material you're using for your infill and therefore your print time by using Prusa Slice's lightning infill mode, where it produces just enough infill to act as a support structure on the upper layers where needed, and it sort of grows it out of the inner perimeters of the model, meaning that the rest of the model below that is completely hollow. Whilst this is the final episode for now in my series on 3D printing and the environment, it certainly won't be the last, and I will be returning to this subject again in the future. In the meantime, however, there is a lot more exciting content on its way to you. Of course, there's going to be more 3D printing tips and tutorials, but there's also going to be videos on experiments and drones and cameras and some fun robots that I've designed and built, which I'm looking forward to introducing you to over the next year. If you've got any thoughts or comments about this series, please do pop them in the comments below, because I'd love to hear what you've got to say. And of course, like and subscribe the channel. It really does make a big difference to me. As always, thank you guys very much for watching, and I'll see you guys next time.